Okay, so I think this was a free response question in the morning. And it is a differential equation. You are pretty much guaranteed also a differential equation problem on the test, so we want to make sure we go over this as well. The first one starts by using Euler's method. Now, a lot of you are still having troubles with this, and I know that some teachers teach it differently than I do. But let me just go ahead and show you the way that I do it and just try to catch on. Because it's an easy question, this one was worth 2 points. So our initial condition starts at f equals 0, and we're trying to, we start at x equals -1, and we're trying to approximate f of 0. So the first thing we have to do is set up our x table. So we're going from -1, and we're doing it with 2 steps of equal size. So that gives us 0.5. So then our next one would be -0.5 and then 0. And our delta x is 0.5. Our initial value when x is -1, y is 2. That's given to us. Okay? So the way Euler's method works is that to find 0.5, I take the previous y value plus my delta x, which is 0.5, and I multiply that by the derivative of -1, 2. So I am putting 1 in for x and 2 in for y to get the derivative. So in this case, when I put in -1, I get 6. When I put in -1, I get 1 times y is 2, so that's 2. So 6 minus 2, which is 4. Half of 4 is 2, so this value should be 4. And then the next value, sorry, I don't have my answers in front of me. Then to find 0, I do it again, and I take my previous y, which is 4, plus my step value, times my previous x and my previous y, evaluated using this x and this y. So that'll give me 6 times a fourth. And I did that wrong because I put in, did I do that right the first time? Because I put in -1, yeah. So that should be 6 times a fourth minus, again, that'll be 1/4 times my previous y, which is 4. And we were doing this without a calculator, so let me see if I can do this without a calculator. That'll give me 6 times a fourth is 3. Okay, I'm going to say this is 6/4 minus 4/4, which is 2/4, which is a half. And then a half times a half is a fourth, so it's 4 and a fourth. And I think that's the correct answer. So that was our answer, or 4 and 0.25, or 9, what would that be, 8, 9/4. Okay, the second one, they randomly threw in a Taylor polynomial, not sure why, but basically to solve this, remember the Taylor polynomial is going to be f of, do we have a center? About x equals 1, so it's going to be f of -1 plus f prime of -1 times x minus 1, or in this case x plus 1, sorry, plus f double prime of x plus 1 squared. So we know f of -1, they gave us that somewhere, it's 2. We know f prime of -1 is, do we know that? We know f double prime is -12, and I'm sorry, this is over 2 factorial. So this would be over -12, 2 factorial, times x plus 1 squared. And I know I can find f prime of -1 simply by plugging it into this expression. So f prime of -1, and I probably already found this on the next stream, but I'll just do it again, is 1 times y is 2. So what is that? 4. So this is 4x plus 1. And that's our Taylor polynomial. Okay, for this one, you had to do a separation of variables. Guys, you have to be able to do this. This is definitely going to be on the AP exam, so you have to be able to do it. A lot of you got mixed up in the algebra here, but what you need to do here is factor out x squared. So we have dy dx is equal to x squared 6 minus y. Then we would separate our variables. We get dy over 6 minus y is equal to x squared dx. And then we integrate both sides. So when we integrate this, we have to use substitution because of this negative. So this ends up being negative natural log of 6 minus y is equal to x cubed over 3 plus c. Now, I'm not sure how you were taught this before, but you always stop at this point and find c. Stop here and find c immediately. I put that on several of your papers. Now, some of you did it later and still got the correct answer, but a lot of you found it later and got the wrong answer as well. So stop here and find c. And we find c by using our initial condition. When x is -1, y is 2. So this would be the negative natural log of 6 minus 2 is equal to -1/3 plus c. So c is equal to the negative natural log of 4 plus 1/3. I know that's a little awkward, but that's what it's equal to. So now that we have c, we're going to solve for y. And that's the other thing. You have to remember to solve for y. So I have the negative natural log of 6 minus y is equal to x third over 1/3 plus 1/3 minus the natural log of 4. I'm going to divide everything by that negative. So I have the I have natural log of 6 minus y is equal to -1/3 x cubed minus 1/3 plus the natural log of 4. To solve for y, I have to raise this to the e power, so I get 6 minus y is equal to e to the -1/3 x cubed minus 1/3 plus the natural log of 4. And all of this is e raised to that. So my final answer, when I subtract 6 and then divide by the negative, I get 6. I get y is equal to 6 minus e to the -1/3 x cubed minus 1/3 plus the natural log of 4. Can I leave my answer like that? Absolutely. I would recommend you leave your answer like that, because if you simplify, you might make some mistakes, but it's okay. The way the AT had the answer written was -6 minus 4 e, because the -4 came from bringing this natural log of 4 down, because it's negative e raised to that natural log of 4. And then I think they factored out -1/3 and made it x cubed plus 1. Okay? If you don't understand how I got this -4, please come see me. This was worth 6 points. This entire question was worth 6 points, I think. Let me just verify that. And if you didn't separate your variables, you couldn't get any of the points. If you forgot C, the most that you could get was 3 points. If you forgot your C, the most that you could get was 3 points. But where did the 6 points come in? 1 point for separating variables. So as you are taking your test, you want to recognize this. You want to see what they're looking for. So you want to make sure you're showing these steps. So you want to show that you separated the variables. You got 2 points for the antiderivative. I gave you If you forgot the negative on this one, I only gave you one of those 2 points. You got 1 point for C. You got 1 point for using the initial condition to find C. So even if your C was wrong, as long as you used that initial condition to find C, you should have gotten a point. And then you got 1 point for solving for Y. You have to solve for Y. You must solve for Y. You cannot leave your answer like this. You have to solve for Y. Now you can leave it like here, as long as you have Y on one side of the equation by itself, but you must solve for Y. Okay? All righty. I think that was the morning free response question.